Okay, now let's recall, how do we decide where the water moves, from where to where? Okay, in order to decide where the water moves, okay, direction of water, you need to know, where is the water concentration is higher. Okay, this is the most important thing that you need to remember. Okay, where the direction of water is to identify where the water concentration is higher. All right. Okay, now the demonstration of osmosis using a Visking tubing. Now you know what a Visking tubing is, right? A Visking tubing has tiny holes. Okay, tiny holes that allow only small molecules to pass through it. It separates a concentrated sucrose, they are bigger molecules, from the water. So obviously, if you look at the diagram here, this is the sucrose. Okay, this is the sucrose. So the sucrose molecules here is bigger than the water molecules. So here is the water molecules. Okay, the water molecule satu is just a dot. Okay, just a small dot here. So of course, this is the semi-permeable membrane. So this is the semi-permeable membrane, and it has tiny holes there. Okay, so this is the tiny holes here. Ni tiny holes in between. Ni tiny holes. Okay, in between is tiny holes. So that tiny holes only allow the water molecules to pass through it. Why? Because water molecules is smaller than the sucrose molecules. Sucrose molecules cannot pass through the Visking tubing. Why? Because it's too large to fit the tiny holes of the Visking tubing. Clear now? Okay, now. So look at this experimental setup. Okay, you can see here is the Visking tubing here. Okay, this is the Visking tubing here. It's tight here. Okay, it's tight here at the two ends. And then inside the Visking tubing, inside Ani is the sucrose. Okay, it's the sucrose solution. Okay, and outside here is the water. Here is the water. Okay, so I repeat,